Lesson 3.5 is on arithmetic sequences as linear functions. And it's going to be the last lesson that we do in Chapter 3. And basically, we're just looking at numerical sequences and then turning those sequences into linear functions or linear equations. Okay? So today we want to be able to recognize arithmetic sequences. So if you have a sequence, can we tell is it arithmetic or not? And then relate arithmetic sequences to linear functions. So we're going to take those sequences and explain how they are linear functions. Okay? Your Common Core content standards come from your functions, and both are about arithmetic sequences. We're not going to talk about geometric sequences just yet. Okay? And then your other function standard is we're going to construct linear functions from them. Okay? Your new vocabulary: sequence, terms of the sequence, arithmetic sequence, common difference, and recursive formula. And we'll talk about each of these as we go through the lesson. Okay, so what exactly is an arithmetic sequence? An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate, called the common difference. So right here, this kind of gives you an idea of where this linear function comes from. We're talking about constant rate, okay? And we use the constant rate, we call it, when we're talking about sequences, it's called the common difference. So if you look at this sequence, 3, 5, 7, 9, 11, you're going up by 2 each time. So your common difference is 2. In this sequence, 33, 29, 25, you're decreasing by 4. So your common difference is -4. And we signify common difference with a D. Okay? So our first example, determine whether -15, -13, -11, -9, etc. is an arithmetic sequence, and then explain. Okay? Here's your sequence. So in order to determine if it's arithmetic, we need to find the common difference, if there is one. And in this case, there is a common difference of 2. Okay? Because there's a common difference of 2, it is arithmetic. This is an arithmetic sequence because the difference between terms is constant. It's a constant of 2. There are other types of sequences. Okay, we talked about geometric sequences that we'll do later, and those are actually, your differences are ratios. We can multiply. Okay, but here we're either adding or subtracting. Okay, let's look at this sequence. Same question. So if you find the difference between each term in the sequence, you can see that they're not common. Okay, they don't go, or in this case, they don't decrease by the same amount each time. So this is not an arithmetic sequence, okay, because the difference between the terms is not constant. All right, so you've got 2 check your progress problems, and all they want you to do is determine whether or not the sequence is arithmetic. So go ahead and pause the video, try these 2, and then we'll check them. All right, so let's take a look here. Here's your sequence. Let's try and find a common difference. We go 2 to 4 to 2 to 2. So you can see right there, this is not an arithmetic sequence because of this 4 right there. If this was a common difference of 2 all the way around, then we could say that it would be an arithmetic sequence, okay, but it is not. Let's look at your next sequence. Okay, if we find the difference between 1 and 2/3, 4/3 and 1, 5/3 and 4/3, 2 and 5/3, we can see that it is actually increasing by 1/3 each time. Therefore, yes, this is an arithmetic sequence because the common difference is the same. Okay, so that's your first skill. Recognize if a sequence is arithmetic or not. Okay, so the first skill we've got down. Okay, the next skill that they're going to ask us to do is find the next 3 terms. Okay, and again, you're just going to kind of work off of what you did last time. You need to find the common difference, and once you know your common difference, then you can find the next 3. So you're going to take -17, and you're going to subtract 3 more, then take that and subtract 3 more. Okay, since the common difference is -3, you're just going to keep going with that pattern. So your next 3 terms would be -20, -23, and -26. But you have to find that common difference. Okay, so take this sequence, find your common difference, and then list the next three terms. All right, your sequence, you get a common difference of 5. So you're adding 5 to each term. So if you take 73 and add 5, you get 78. 78 plus 5 is 83. And 83 plus 5 is 88. So there's how you get your next three terms. Okay? All right. Now, the next logical question is, well, what if I don't want to find the next three terms? I want to find the 50th term, or I want to find the 10th term. Okay, we have to find a way in order to, instead of writing out all of the terms of the sequence, we have to come up with some way, like maybe an equation, to find a certain number of the term. And we're going to do that by using this formula right here. And this formula will help us out a lot. Okay? Each piece of this represents something different. Okay? A sub 1 means that is the first term of the first number in your sequence. N is the number of term, what we're trying to find, the nth term. Minus 1. D is your common difference. We've already talked about that. Okay, we already know what D is. So your A sub 1 means just the first term in your sequence. D is your common difference. So we're going to use that formula to help us find the nth term. Okay, so your first example. Write an equation for the nth term of the arithmetic sequence. So here's our sequence. The first thing we have to do is find the common difference. And if you look, you can see that each one of those go up by 9. Okay, so once we find the common difference, in this equation here, we now have our D. Okay? The next step, let's take that equation and plug in what we know. Okay, we know that the first term of our sequence was 1. If we go back and look at that sequence, our first term is 1. So that's why there's a 1 there. It's the first number in our sequence. 9 is our constant, is our common difference. Okay? So what we have to do is we have to take this part right here, and we need to simplify it, because that's going to be our equation. So the first thing we need to do is the distributive property. 9 times n, 9 times 1, we get 9n minus 9. Then we need to add like terms, 1 minus 9, and we get 9n minus 8. There is our equation. Okay? So what this enables us to do, since we now just have n in there, we can say, find the 12th term. Well, since we already have our equation, and n is the number, is the term, all we have to do is plug 12 in there. 9 times 12 minus 8. And see how they put that 12 right there, that subscript? That means we're finding the 12th term. And whatever this is, this works out to be, whatever this works out to be, will be our 12th term. So our 12th term is 100. This formula right here enables us to find any term in that sequence. Instead of writing out to the 12th term, we can just now plug 12 in. Okay, then what they want you to do is graph the first 5 terms of the sequence. This is the linear equation. Okay, here's your formula, 9n minus 8. The first 5 terms, 1, 2, 3, 4, 5. Your n is your number of term. So since they want the first 5, we just use 1, 2, 3, 4, and 5. It's like an xy value chart. Here are your x's, here are your y's. Or here's your input, here's your output. Here's the machine that you guys came up with, 9 minus n. And then here are your 2 points. So you plot them, and you can see that it's linear. So arithmetic sequences are linear functions. And then D, which term of the sequence is 172? So now we've changed it up a bit. Let's go back to our formula. They're saying what term, what is n if we have 172? So we're plugging in 172 right here, solving for n, and we know that 172 is the 20th term. So in this case, we're solving for n. Okay? All right, so you now have 4 pieces, okay, and that's one example. they want you to check your progress. They want you to do the same thing. So go back, use that example to try this problem right here. So go ahead and pause the video. Okay, the first thing we want to do, let's write an equation for the nth term. Okay, so we've got to, here's our sequence. We need to find the common difference so that we have a d. We know that our first term is 2. Now we know that our d is 5. Let's use our formula, okay, and plug in what we know. A sub 1 should be 2. D should be 5. Okay. Distributive property, 5 times n, 5 times 1. Simplify, we have 5n minus 3. So here is our equation. And this will help us find the number in our sequence or a term. Okay. All right. Let's find the 12th term in the sequence. So let's take what we just found out, and we want to find the 12th term. So what we're going to do is plug 12 in for n. Okay. So the 12th term is 57. Okay. So if we wrote our sequence out, the 12th term would be 57. Which graph shows the first 5 terms of the sequence? Well, you can do an xy value chart, 1, 2, 3, 4, 5, and you can plug in your x values here. Your first term is 2, your second term is 7, your third term is 12. This graph represents those points. Okay. And lastly, which term of the sequence is 97? So you have 2 options. You can use the formula, which I want you to do, or you can take your sequence and keep listing out the terms or the numbers of your sequence till you hit 97. That's the long way to do it. Use your formula that you found. 97 is this number right here. Okay, so then we have to solve for n. So we're going to add 3 to both sides, divide by 5, and you get 20. So 97 is the 20th term in that sequence that we started with. Okay? So that's the video for arithmetic sequences. We will come in tomorrow and get started.